Large circles have the same radius, which shaded area is the greatest. Now you could work in terms of a general radius, but I'm going to make it just a nice number 2. And the reason I've gone with 2 is that for this first one, I then get a radius of 1 for these smaller circles. So the shaded area for this first one is going to be pi times 1 squared for one circle, just times that by 2. So I'm going to get 2 pi. I can leave my answer in terms of pi, but I think, I'm just going to approximate it as 3.14. So then I'll get 6.28, or I should probably write down approximately. Okay, next up, do you know what? I think I'm going to go with the circles and squares first, and I'll come back to the triangles. So for C, let me draw a little arrow to here. Okay, remember I've said that this is 2. So the square length is going to be 4. 4 times 4 is 16. So I'm going to get 16 minus pi times 2 squared, which is 16 minus 4 pi. I just need to double that 6.28 from earlier. It's going to be 12.56. You can clearly see it's going to be smaller, but I'm going to continue to calculate them anyway. 3.44. Well, I should probably, again, I should say at this point it's approximately. Let me deal with the other one. So again, I've got pi times 2 squared, but this time I've got a slightly different square because this whole length is 2, which means that is 2. So it's actually, for my square, I've got a diagonal that is going to be 4. And then I want to work out the lengths of the sides. Now, a quick way to do this, because it's a 45-degree triangle, is just to divide through by root 2. I'm going to get 4 over root 2 for both. And therefore, the area is going to be 16 over 2, or 8. So it's going to be pi times 2 squared minus 8. Before I calculate that, let me just explain where that's come from. So in general, if we have a length here as x, then I'll call this y and y. So y squared plus y squared using Pythagoras' theorem is going to equal x squared. That means 2y squared is x squared. So y squared is x squared over 2. Y is x over root 2. That's how I knew to just divide through by root 2. So 4 pi, which we calculated before, is 12.56 minus 8. And that is going to get me to 4.56. Okay, so we can see that E is not the answer and C is not the answer. A is winning at the moment. Next up, I'm going to go with D, the triangles. Actually, this turns out to be the quickest one of all because remember, that is just 2 and that is just 2. So I'm going to get a half times 2 times 2 for one triangle. But then I just need to times that by 2 because there's 2 of them, which leaves me an answer of 4. So again, it can't be that one. I'm just left to find out what B is. Okay, now I can start from the center and I can draw a line here, which is 2, remember? And I can draw a line going up. Now this angle here will be 120 degrees. So a really nice way to do this question is to work out what one of these little triangles is. It's going to be a half AB sine C, a half times 2 times 2 times sine 120. Sine 120 is actually the same as sine 60. I'm kind of going into quite far into sort of GCSE maths right now with this kind of stuff. If you look at the sine curve and you know about it, then it's symmetrical about 90. And so 30 above 90 is going to be the same as 30 below 90. It's the same as sine 60. The half and the 2 cancel, so it's 2 sine 60, which is actually root 3 over 2, which ends up being root 3, which is about 1.7-ish. Remember, that's just one of my little triangles. So I can now do 3 lots of 1.7 to give me 3 plus 2.1, 5.1. We can see it's a lot smaller than A. So our answer is definitely going to be A. Now let me go through that in a different way because I feel like that was very quick what I just did there. For B, and I'm going to try and not use like non-right angled trig to do it. I'm going to do it without to demonstrate that we can, in fact, do that. Okay, so method 2, I am again going to draw this in. Now this here is 30, and actually what we get um, is a triangle with 30 and 30 here, and I can imagine like getting rid of that and moving it to here, because this will create an equilateral triangle. And the one length of this equilateral triangle is going to be 2. So I'm still doing this orange area. I'm going to show again it's about 1.7. I'm just doing it in a slightly different way because I just want to say again, and it's worth being aware of this. I've seen Olympiad problems that use these ideas. Very useful stuff here. So I just want to say again, we've got our isosceles triangle with 30 here and 30 here, and draw a line down the middle and imagine like just moving this bit round to create this isosceles triangle, side length 2. They will have the same area. So I'm going to split it into 2 again, but what we can see now is that this is 1, and I could do Pythagoras to get root 3 here. And therefore the area, without doing any trigonometry, is going to be a half times base times height, so a half times 2 times root 3, and we're back to getting root 3. Okay, no trigonometry required. Again, you just have to be aware that that's 1.7. It's worth knowing a few numbers like 1.5 squared. Well, 15 squared is 225, so 1.5 squared is 2.25. That's too small. 16 squared, 16 times 16 is 256. So we get 2.56 here. 17 times 17. Actually, I don't know that one off the top of my head, but I'm going to do 170, like 10 times 17, and then plus 70 plus 49. So 240. Oh yeah, 289. I should have remembered that. So we get 2.89. So when I said it was about 1.7, okay, it's a bit less than 1.7, but it's still going to be way off the 6.28. If you go with 18 squared, it will be, I think it's 324 18 squared. So that would be too big. You don't need to do any more decimal places, but it's enough to say it's about 1.7. And then, anyway, hopefully I've convinced you that it's much less than 6.28, that the answer is A. And I've used a slightly different method to work out the area of B than I did originally. Probably a little bit easier to understand, so maybe I should have done that to start with. But there's more than one way, and if you do know about the trig graphs and everything, then this is a little bit quicker, I guess. Well done.